C language categorizes its variables. There are integers, type int, such as -3, -2, -1, 0, 1, 2, 3, etc., going this way, and etc., going this way. But there is a restriction or constraint on them. You can put numbers into an int, which is 4 bytes long, ranging from -4 billion and change to +4 billion and change. Long integers are called long-longs. Really, they called it long-longs. And it's 8 bytes long. And the range for long-longs are from -2 to the 63rd power to +2 to the 63rd power. I put that into the Excel program and I came up with this number. That is a huge number. And there's another variable type called char, or if you're from England, char. And it's 1 byte long. It's from -128 to +127. Those are the range of values it can hold. And there's a variable type called float, and you can have up to 7 decimal digits of precision here. 7 decimal digits. No more. Then there's a data type double, and you can have up to 16 decimal digits of precision here. 16, and no more. After that, it doesn't hold anything, as you'll see in a moment. So we start our program in Visual C, and the system automatically puts stdafx.h in there, but I put in #include stdlib.h. I need this guy. He's got definitions in it that I need, as you'll see in a moment. Then I start off my program, int main. And over here, I've got the arguments that'll be caught by our function from the calling function or calling person. In other words, if you key in the name of this program and pass it some arguments, they'll be caught here, as we discussed in the previous video. Here are the curly braces, and our code is contained herein. So, let's begin. I declare a variable called mcb. It is of type char. And I assign it the value b, the letter B. I put it in single quotes, and I end the statement with a semicolon. All right. Next, I call the printf function. I call the function which will print out this data, the printf function. And that is defined in stdlib.h, which is why I need this guy. So, print function, yes, I'd like you to print something out. Really? What would you like me to print out? I'd like you to print out 2 carriage return line feeds. Okie dokie, I'll do that. And a tab. And this / character over here makes this work. Okay, these are escape characters, and there's \n, \n. Those are 2 carriage return line feeds. \t, that's a tab. And then I've got these 2 funny characters over here, these format specifiers over here, %i and %c. And I've got 2 variables, mcb and mcb again. And these 2 guys map to this guy and this guy, respectively. The first guy maps to the first format specifier, %i, and the second variable maps to the second format specifier, %c. I'm going to take mcb, which is the letter B. I'm going to print it out in the format of an integer. I'm just going to say equals, well, integer? Yes. The computer represents this letter B as a series of zeros and ones. And the system behind all of this is Unicode. And the Unicode representation of B is 01000010. So that, which is 66. That 66 will equal what? Well, I'm going to take MCB again, letter B, and print it out as a %C character. So it'll say 66 equals B. Okay, that's rather cool. I like that. And then I drop down to the, and close the parentheses, and I put in a semicolon. And now I call the function called system, which is defined in stdlib.h. And I tell it, pause the system. And don't do anything till the user strikes any key. And then he does that. All right, then a semicolon, and return 0 when the program is over to indicate that it functioned well. And then into the curly brace. That's it. Program runs. We run the program, and 66 equals B. Wow, it worked. This is press any key to continue. That's your pause. Let's take a look at one more data type, and that was the float and double. One more program. We'll look at two data types, float and double. So once again, I include stdlib.h because I'm going to call the printf function and system again. Same functions, but different data. So I have int main. Main's going to return an integer, 0. And it's going to catch any arguments we pass to it. We're not going to pass any arguments to it, really. And let's see. Here we go. First variable I create is called memory float. It's a memory variable called float. I've just put the m in there because I like that. It's not required. You could give this any name. So I get a memory variable float, mf. And it's of type float. This is required. You have to put in the data type. So this is a float variable, and I'm going to assign it the following values. Period. It's going to be decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10, 11, 12, 0, 1, 2. Now I put in more values than this guy can take. I did that on purpose because when I print this out, I want you to see what happens. And when you put in more values than the variable is built for. And then I have double, a variable of type double called MD, memory double, equals dot 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So I get 20 numbers in here, but this guy can't take anything more than 16 decimal digits. This guy's 7 up here. The float 7. After that, let's see what happens to these. This guy's 16. Let's see what happens to these last 1, 2, 3, 4 numbers. That's 1, 2, 3, 4, 5, 6, 7. What happens to this guy? 8, 9, 0. I wonder what it will do with these guys. I wonder what it will do with these guys. 7, 8. Okay, print f. I'm going to call the function called print. I'm going to pass the 2 character return line feeds and a tab. So it'll hit the enter key twice and then tab over. Then the format specifier will be different. This time I'm going to key in %.12f. Give me 12 places for data display. Okay, but this guy only takes 7. Yes, I know. I want to see what happens to him. And then 2 character return line feeds, and then pass mf to this format specifier and print him out. Okay? So the float mf will get printed out. Next, I'm going to call the print function, character return line feed 2 times, tab over twice, and then my format specifier will look like this, %.17. That's 17 places. Gee, I wonder what's going to happen to this guy right here. I have 890. What will happen to these numbers? And these guys over here, 89012. What do you think's going to happen to those guys? Okay, let's see. And then I tell the system to pause everything so that I can see what's being printed on my screen. Return a 0 after I hit any key, and the program will run. All right, let's take a look at this now. I run the program, and first value 1, 2, 3, 4, 5, 6, 7. That's it, the limit. And then, whoa, look at this, 9, 1, 0, 4, 3. Let's take a look at that. What came after 7? 8, 9, 0, 1, 2. 8, 9, maybe he rounded it off. Well, where's this gobbledygook? 0, 4, 3, 0, 5. That's all gobbledygook now. But that 9, that 8, 9, whoops, gets turned into a 9. 1, 2, 3, 4, 5, 6, 7. And the 9th and the 8th one mysteriously is a 9. But I don't have a 9 here. I have an 8, 9. Could it be it's trying to round it off? What about the next guy? 1, 2, 3, 4, 5, 6, 7, 8, 9, 16. 16 places of decimal precision. And then the next few characters are 7, 8, 9, 0. Let's see what happens to this guy. And the last few numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6. Whoa, it's an 8. Let's look at the value again. And 6, 7, 8. Is it rounding it off? It looks like it's trying to round it off. I'm taking that guesstimation from this and this. It looks like it's rounding off that last decimal digit. Then I get nothing after this. With this guy, it looks like it's rounding it off, and then it sort of gives me gobbledygook. Garbage. Wow, that's amazing. And this is George Boole. Thanks so much for listening. Bye-bye now.